A very good afternoon to all present here. It's my pleasure to be part of this mega event organized by Caho. I must appreciate, and I have been hearing this, programs this morning, so I must appreciate the efforts put in by Caho team, ensuring our healthcare system in India become stronger and stronger and safe. So with that, I will start my presentation. I would like to be for a while on this cover page of my presentation here. The left side, you see that the topic, what I'm going to talk about, what matters most in the medical gas system. But before that, I'll talk about what matters really, which we didn't know. I think you mentioned that even as the most critical thing, we came to know, though it is used by all the hospitals, very critical, life-saving we call it. But we came to know the importance of that critical thing during COVID, that is oxygen. We in Linde, before I just take a couple of minutes here to talk about that, taking the opportunity here in this forum, a lot of people from the healthcare industries. So before COVID, the first wave one, India consumption used to be 850 tons per day, entire India consumption of medical oxygen. And I when this crisis started, wave one, I got the opportunity to work with central government, DPIT, as well as each state government, principal secretaries and all to look after oxygen supply, oxygen allocation. And so you all know that wave one, the oxygen consumption was not that high. We were fortunate, but it was definitely given us a lot of trouble. And wave two, when oxygen consumption, because of the symptoms and all, sudden need to increase the flow of oxygen on the ventilator and all, and suddenly the oxygen consumption started going up. And you all know that oxygen consumption in the crisis, it had reached to 9,000 tons per day, from 850 tons per day. That's the increase, that's the surge in medical oxygen. And we are very grateful, thankful that we in Linde could really work. Our team sitting here in the corner, our healthcare team, all the teams sitting here, and I think they ensured that across India, we could supply oxygen by engaging this ISO containers. You all know the ISO. We are the first company imported ISO containers, from Linde, multiple locations in Singapore, Malaysia, and all, and work very closely with the government. I know the Kerala government also, the principal secretary. We have been talking that how fast we can supply these oxygen containers through Oxygen Express to the state, and we could supply 3,200 tons per day. There's 1/3 of total requirement in India during the crisis. So thanks to all the support from the government, the state government, and our healthcare team sitting here, I just wanted to touch upon. So the oxygen critical, how it is. I'll quickly take you through the Linde before we go to the main topic about Linde was leading industrial medical gas and engineering company. We make plants also. We make plants which make oxygen, apart from supplying oxygen. Linde Healthcare has been a leading supplier of medical gases across the world for more than 130 years. We live our mission of making our world more productive. That's our mission. Every day by providing high-quality solution, technologies and services which are making our customers more successful. The right side of slide, I'll not spend much time. So it's a $31 billion company as per last year data. We operate in more than 100 countries across the globe. And we try to establish where our customers are so that we can serve them better in a very short time. Globally, our healthcare contribution around 20% of our total business. So that's what we deal with. We deal with a lot of other industries, and healthcare is one very critical segment, around total 20% of our total business size. So moving on to next slide. This is very, very critical here, dedicated to service of India. This is India, particular for India. We are last 85 years. You all know that I just touched upon Linde and Praxair. Like say, I think Kerala, we have a lot of Praxair customers where we supply medical oxygen to all the renowned. I've been meeting a lot of doctors, very senior officials. I got opportunity to meet after so many years. So Linde and Praxair got merged. It's an equal merger 2 years back, and that's what the India total 85 years we have been supplying. We have got more than 400 customers where we have installed tanks and we supply liquid medical oxygen. We have more than 850 customers where we supply oxygen through cylinders or quad or MCP. We have nitrous oxide. We have got a state-of-art plant. I think this is the only plant in South Asia, I will say that, in Hyderabad, where we make nitrous oxide. And we supply in liquid form. This is the only company we supply liquid nitrous oxide in tankers, and we supply in cylinders also. More than 700 hospitals what we supply nitrous oxide. The another product, I think somebody was talking about in the morning about C-section, right? So there's another product, very important product, I think, Internox, with a mixture of nitrous oxide and oxygen, 50-50, and which is used to have this painless birth, a baby, normal delivery. So we are working on that to ensure that, I think, how to reduce this C-section and improve the normal delivery in India. It's very high. You all know that the C-section is very high in India, and that's how, that's very easy thing to go for it, but with a lot of pain. So this gas, this mixture with a lot of devices will help. I will request that please visit our stall. Linde stall is there. We have got demo. We have got Internox, which the gas I'm talking about, how it is used. We have got LIV. We have got various things what we deal with. So that will create a lot of awareness, and then we can definitely help industry here. Other equipment you'll see in our stall is NOx box. NOx box is inhaled nitric oxide delivery system. It is mainly used for organ transplantation, mainly. This is the device what we have got a demo in our stall. PSA is a very familiar name. Like after COVID, the government mandated that every hospital should go for PSA. The pressure swing adsorption plant, on-site oxygen plant, we also deal with that, but we don't deal with that. We don't sell the plant. Our belief is that hospitals, their core competency is to deal with the patients, not with the plant and engineering and machines. So I think that's what we deal with, and we try to take the responsibility and run the plant for hospital. I don't want to sell plant to hospital and put them in trouble. And LIV, LIV is the Linde integrated valve, very special, sophisticated cylinders, aluminum cylinders, very small, lightweight, which used in ambulance and transfer the patient from one place to other place. With that, I will move to the topic, today's topic. So I have divided the topics in two parts. This is what matters most in medical gas system. So two parts. One is that the delivery system, like say within the hospital, delivery medical gas pipeline system. Other part is that installations, where you store oxygen and supply. The first part, what I'm going to talk about, that is medical gas pipeline system. The very critical part, normally I know there are a lot of players in market who basically lay the pipeline. But for us, it's not just laying the pipeline. We call it MGPS supply system, which has got a lot of things to deal with. And we execute. India, I think there's no standard as such. There's a standard HTM and NFPA, what we follow that. You all must be knowing that Health and Technology Memorandum, that is UK, that's a standard we follow for drawing and operation. That's a very critical part, very, very important when you go for the medical gas pipeline system in the hospital. And there are two parts of this HTM 0201, part A and part B, which we strictly follow for design, that is part 1, and for operation part 2. And other one is NFPA. NFPA, this is the National Fire Protection Association, US, and NFPA 99, the guideline came in for designing the supply systems and the building management systems and all safety, security, and all this in the hospital. Other very critical part, I think I have seen some of the hospitals where the pipeline has been laid, but you can't make out which pipeline will carry what, right? You will have oxygen, you will have vacuum, you will have compressed air, you will have nitrous oxide, but you can't make out. So we ensure that the color code is followed, in that system. So we have got a color coding, and it's very, very important. There's a different colors for different gases. Like oxygen, we have yellow color with the white band, right? Yellow color, white band. We have got compressed air, blue color with black and black band. Black and white band. Vacuum pipe, blue with black band, and nitrous with blue with yellow band. This is a very, very critical part. Anybody, even the people who are not trained for that, seeing that color code and there's a display, this color is this product. So there won't be any mistake, any problem in the hospital. That's a very critical part in the MGPS system. Similarly, this adapters. Another important part is that you must have seen the outlet, the bedhead panel, or near the bed, the outlet, the 4 buttons will supply the various gases, and the adapters. By mistake, if somebody's remove the adapters, okay, so there won't be any problem. You can't fix it. Say oxygen adapter, you can't fix the vacuum pump adapter, a vacuum line adapter, or you can't fix the nitrous oxide adapter. That's our standard. We follow that, and that's a very critical part, so that there's no issue or problem in the hospital in the supply system. So I was talking about area wall service unit. So area wall, what we do that, we divide the total area in couple of parts, like say ICU or this theater, operation theater, or the ward and all, and we put the isolation wall. We put the isolation wall so that there's no, if there's any problem in any of the ward, that can be controlled, that can be taken care without stopping or disrupting the supply in other places in that hospital. There's the alarm unit. This is a very critical part of this MGPS system. The alarm unit, every unit, what I talked about, we divide that, will have the alarm system. If there's a drop in the pressure, the alarm will activate. And we connect that control to the control room, like say maintenance room, wherever the people are controlling this thing, they will come to know that which area of the hospital has got low pressure or the pressure is dropping. So immediate action can be taken. Then there's the pendant, bedhead panels and all. We follow same STM0201. And the manifold with the control panel, the semi and automatic. There's the auto changeover. We follow that. If there's a drop in the pressure, it will shift to the other line of the manifold so that there's no stoppage of supply. AGSS plant, there's another important thing to take out this hazardous gas from the hospital out of the building to the pipeline. But another thing, I think these are things when we have a discussion with the hospitals, we make sure that these things are considered and we create the awareness, the hospital go for it. I know it's a little costly, but it's very important for the system. And the definitely vacuum plant and the bacteria filter is another important part of our MGPS system, the bacteria filter. People give filter, but we give 100% bacteria filter. The next important part of our medical gas system is that, is the tank sizing. So it's not something like that we, on our own, will go to hospital and just put the tank based on our understanding. We have a discussion with the hospital. It's very important. All the hospitals should understand that. What would be the requirement? How many bed hospital it is? What could be the flow? How many OTs? This is what we consider. Then we see how far is our source? What is the time required for transit, right? All this we discuss with the hospital and decide on the tank sizing, which is a very critical part. We have experienced that during COVID. That was the surge in the requirement. Even the normal requirement, if there's a peak or there's an increase in the consumption, your tank sizing, if it's not adequate, can't take that requirement. So we work on that. We ensure that the hospital has got a suitable size of tank, in consultation with hospital. And we also explain them what could be the operating stock, what is the risk assessed stock, and what is the usable stock. We explain them why this size is required, okay? The second important part is alarms. So alarms we put in 2 parts. One is in tank, we call it primary alarm. So if there's a pressure fall in the tank because of the level low and all this, the alarm will get activated. The maintenance team or whoever is controlling that, they'll come to know there's a risk here. And the risk is not something that end of that. You will have the cushion to plan. So there's one. And second alarm we provide in our downstream, spool, where if there's some problem, the pressure goes down, and that could be taken. So you can see that in the picture here, I'll try to draw your attention. The right side on the tank, the small blue color, that is the telemetry unit. This name is very familiar now. Linde installation across India has got telemetry unit. It was not known to anybody what is the telemetry. Now, government has mandated that telemetry for all the hospitals. Anybody who owns the tank must have telemetry. That detail was given by us. What is the function of telemetry? So there's a contact gauge on top of the tank connected with the telemetry, the pressure gauge connected with telemetry, and through satellite, the data goes to our control room, okay? And we monitor that, our people 24/7, what is the consumption pattern, what is the level, and based on that, they plan the tankers. So that there's no risk, there's no shortage of oxygen in hospital. Hospitals do not need to plan the supply. They need to plan the patient and their treatment. The oxygen supply should be planned with this automated system and by our people. That's what it is. I think that's the two systems we talked about. And quickly, I'll talk about other things like I mentioned about number of beds. So we have got some standard based on our experience, how many beds, what should be the consumption, like say 50 bed, 3,000 cubic meter or 100 bed, depending on how many OTs you have got. So these are things we discussed before we plan the system for the hospital. These are very critical things to understand before we go for any installations. And there are PSOs, what you can see here. We have got cylinder supply, we have got liquid cylinder supplies, we have got tank supplies, and all these things are there. So that's how we plan and select the PSOs for the hospital, suitable PSO for the hospital. So I mentioned about the PSA. We also deal with PSA, but this PSA is very different in the sense that purpose is same, producing oxygen on site, but the different is the model. We don't sell the PSA. We go for O&M, 15 years contract sort of thing. Zero capex from hospital. We run that PSA and supply to hospital with the automated changeover system. Something goes wrong in the PSA, it will change over to the manifold secondary, we call it secondary supply system, so that there's no issue of reliability in the hospital. So with that, thank you so much for the time, and then thanks to Caho for this opportunity, to share some of the understanding, some of the knowledge about what we have about oxygen, and be safe. Any question, please feel free to ask. Thank you so much.